Hello, 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 hello. Hello, hello. Hello. Hey, maybe while waiting the others to come, right? Let's give back the test paper first. Hey, you help me. Can we call the name? Yeah, I'm going to come up. Let me find some. You just call it. Oh, okay. You don't. I mean, you just read the name. Yeah, and then call it. Yeah. Yeah. Once your name being called, right, you just collect. Yeah. Later we'll discuss it. So I get my mark. Yeah, just a minute. I don't know how to pronounce. Okay. Abby. Case. So, 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 so. Bình泽. Yên. Xuyên. Đi chọn. Để mấy nó biết. Để mấy. Cứu sinh. Gia业. Tổng结. Phú tổng结. Ủy với. Liễu Chính. Liễu Chính那边。真诚。Yeah.严谨那边。江城。一丁啊，还是看一个。Link not here. Hey, Shilin here. Shilin here. Hey, where's your friend? Another one? Minh Siu all 呢？
做特 diet 啊？
Why? 金鱼 how come? 金鱼袁家还有家海人云林张秀陈烨可以丁一起，sorry 银旗，sorry yeah 金 student ID and full name 做宁是海燕Michelle 玉金那边叫邓 not here Ryan 嘉文Hello. You could wait. Read first while waiting. Also waiting for IT. Hi, Jermaine. How do you think? Lee and thank you. Before Dido. 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 Oh, also got this cheat sheet. Yeah, so talking about cheat sheet, right? Three of you break the rules, right? So 本页, 严谨 and 规则. I say only handwritten, right? 1 pages, 1 double-sided. Okay. So please follow rules, right? Okay. Otherwise, you'll get punished next time. Okay. So this time I decided not to take any action, but for future, right? Please follow rules. Okay. Any rules you need to follow, please follow. Otherwise, you'll get punished. Hi, Wai Qi Feng, and Yan Jing. Come get your exam. So today, without mic, without spec, I'm blur and blind. So today I might need to turn on the light, otherwise I can't see the screen. Uh, while waiting for the IT, not sure will come or not. Can I ask some how to say feedback on the exam? Some of you, from some of you. Very hard. Okay, cool. Very hard. Anything else? Not enough time. Okay. Anything else? Very hard. Not enough time. Why? Can you share your analysis last time to them? How about on this side? Okay. 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 Is what? Oh, assignment. Okay. Hey, you mentioned about the time, right? 100 points. 1 point equals to 1 minute. Yeah. You need to know what to do. Yes. That's right. That's right. Okay. Right. This is the setting of this question. This exam paper. Yeah. Okay. So everyone is working under the same uh stress or pressure environment. So this is fair because everyone experience the same thing. Okay. This exam paper, right, is almost the same level of what I did before. And this, I'm not disappointed with this result because this is also the result happening in my university. It's the same. Okay. So this is just part of growing process. Okay. So I want you to learn how to face your failure and then try and find out what you still don't know. Okay. There's no point for you to do question that you know. Okay. Moreover, this question have answer. I can show you later. Okay. And some of the answer is really simple. Just you never thought of it. Okay. This is what I'm gonna to teach you with these hard questions. Okay. So mathematics degree, I hope, is not just about applying formula. Okay. It teaches you how to think. Your mind is your weapon. Okay. Not calculation. Your weapon is your mind. Okay. This is max degree going to teach you. Without this, you are just an ordinary person. Okay. Maybe worse because you don't have other skills. Yeah. So at the same time, you also give me a result, right? Evaluation. Okay. Uh, so we both evaluated each other. Simple. Simple. Okay, so we both evaluated each other. Okay. So I'd like to take this opportunity to apologize if you think that some of time at some point my manner is not appropriate, inappropriate. Okay. I doesn't mean those. I doesn't mean bad to you. Okay. Sometimes I laugh. It's just because I think it is funny. Okay. It's nothing personal on you. Okay. And what should I say? And actually, this evaluation is also quite interesting because I get two contradictory statements. Okay. I get two contradictory statements. Okay. I can summarize a bit. So let's talk about small problem first. So big problem is you think that the assignment is hard. Okay. So we will address it later. And then there are two contradictory statements here. Okay. One thing is about the lecture notes. Sorry, I didn't bring my spec. So I need to focus a bit. Yeah, I mean, we need to discuss this first, fix the direction of our course so that you know how you manage this course. Okay, this course is a little bit different from the others. Okay, first of all, I'm the first time lecturing here. Okay, second of all, the reason I'm here is because Darren said once, I mean, he promised one thing to me. Okay, he said that SMUM is trying to build a serious maths department. That's why I'm back. Otherwise, I won't teach in Malaysia University because it's not worth, because they are not ready yet. The student is not ready yet. The whole system is not ready yet. Okay. I just asked him one thing, whether this university teach epsilon delta definition or not. If the school teach this, only I come back. Okay. I can choose to become any profession I want. Okay. I don't need to use my brain here. Right. Okay. So that's why I won't compromise with the standard. Okay. But I will reduce a little bit the difficulty of the assignment, but I won't compromise the standard I want to make here. Okay. Maybe it's a bit misfortunate that you are the first batch, so I'm still testing stuff. Okay. But rest assured that your point or your score, okay, only represent your ranking. Okay, I will do appropriate scaling afterward. Okay. But of course, if you do really bad, it means you do really bad. Okay. Really bad, I mean. So the only thing you can do in this course is you need to work to your best. Okay. If you work to your best, you will get what you want. That's all I can say. Okay. If you keep complaining and doesn't want to do, then you won't get anything you want from this course. Okay. Okay. So one thing people say here is, yeah. Okay. So one bad thing on the lecture note is the written notes are a bit distorted and it is not suitable for revision. Okay. So I want to make first commitment is I commit to make the lecture note better. So if you think that it's not good, please let me know. Okay, and then I will see how to improve it. Okay. Why I say contradictory? Because the other students say his note is also very clear. I feel like I can understand everything that he wrote here. So you see, this is really a small society here. Okay, one society can break into two sides. Depend on how you see the things. Okay, a good things can become a bad thing. A bad thing can become a good things. Okay. No worries. If you think that it's distorted, just let me know. Okay, just let me know. We still have another half term to go. Okay, two more things before we reach to the difficult assignment stuff. Okay, so some easy theories teacher explain it in a very complicated way. Okay, actually this one got two students agree. Okay, so there might be some problem here, but one student also says explanation in every theorem. I really learned a lot. Okay, so one way I think maybe I make it complicated is maybe because of my oral. Okay, sometimes I get stuck. Maybe you are hard to listening. So this is one of the things I'm trying to improve. Okay, this is my second commitment. And then maybe sometimes I screw up a little bit. Okay, so make you confused. Okay, so I will apologize as well. Okay, I still commit to do the same. Okay, so this is about this explanation stuff. And then okay, another thing is oh, please, I don't know about this question, this student here. So this particular student write quite long. Okay, I don't know who are you because these are anonymous. I don't care also. So it says that please give the students a fair and impartial score. Okay. So if you think that you don't get the right score, just talk to me. Right. Every time I discuss, I give you back. It's exactly because let's say if I make a mistake, you should come back and then take the marks. Okay. Why would I want to give non-fair or non-impartial score, right? There's no point. Okay. So if you deserve the point, you just come to me. Sometimes I just make a mistake. Okay. Just come to me, okay, and discuss. I'll give you the point if it is your point. Oh, another thing is please ask teachers to stop requiring every student to ask questions in front of the class. Okay. Another student say, the lecturer pushes us to ask questions a lot. I think that is a really good thing. I think he's very passionate about what he does and cares the student understand the concept. And then that student actually says some things that I'm really disappointing. Please consider the thought of students who are afraid to socialize and are more introverted. Okay, maybe I ignore your weakness. Okay, I try to push you. Okay, that's my problem. But in the end, this course is not trying to make you more introverted. Okay, you have to speak up. I'm trying to make you communicate. Okay, this is a real story. Let me tell you. One day ago, the student from Max Help Center tell me, because in the Max Help Center, you need to help student, right? You need to explain, right? Okay. He say, I don't know he or she. The person say, I don't know how to help them. I don't know how to explain, although I know how to do. You see? You see a problem or not? Now you still are first year. You don't see anything. You don't know what is going to happen in the future. Okay. You just see yourself. So please don't be narrow-minded. Okay. Please don't be narrow-minded. Okay. Please be mature. Please grow up. I already heard a lot of story like math student creating problem in the final year or what. Okay. So we need to change starting now. First year. Okay. So if you think you don't suit to this degree, you should change it now. You don't wait until third year. It's wasting your life. Okay. It's, it's, it doesn't say that you are not good, but maybe you are more suitable for the other stuff. Okay. There's no good and bad here. Just trying to figure out what suits you the most. Okay. If you will try to stay here, good. Do your best. Okay. If you still keep trying to live inside your comfort zone, I cannot help you. Nobody can help you, not just me. I hope I make this clear. Okay. I hope I make this clear. Okay. So please listen to what I say. Okay? And then we can discuss. No problem. Yeah. So everyone agree on the difficulty of assignment and tests. So I also want to make this clear. Everyone agree on this. There's no disputation here. So I agree on this. Okay. It's hard. I want to tell you, this course is not as easy as you imagine. Okay. You don't compare other lecturer with me. First of all, different lecturer have different stuff. Okay. I have my own mission to do also. Okay. Since you're under me, so we have to work together. Okay. Is it clear? Okay. So why do I give you hard questions? Anyone can answer or not? Yeah. First of all, to challenge us. Okay, sure. Not just challenging. You might think that I'm torturing you. Sure, I'm torturing you. So what's the point? What's the point here? Anyone think of it? Sorry. Sure. Differentiate. That's also not the final point. What's the final point? It must be something good to everyone. So sorry. First of all, the skill to handle difficult questions. So what's the skill? What's the skill? Basic? Basic, you're saying basic, is it? First of all, the basic, okay? You need to understand what basics you have learned. And then? Sure, to be persevere, sure. Okay, good. What else? Still, the most important thing, I keep stressing in this class, the one element. Huh? Good reasoning. Communication skill. Something that you don't know until you know. Okay? And then you need to explain to people how you know it. You need to convince people. Okay? Communication. Reasoning. Make sense? So can you see that why the second assignment I put so many hints there? Step by step, how to convince people. It's not just hint. It's just not just proof. Not just proving why E is irrational. I don't really care. Does it make sense? Yeah, I mean, because it's also your first time seeing this kind of test, I understand. But I really hope that you should see something different after you do this test, okay? Or after you go through this course. Even though if you choose not to continue in maths, that's fine. But in your life, you still need to face this kind of problem. Sooner or later. Okay? So is it clear how we should proceed in this course? Okay. So I want you to treat every theory seriously. Okay. Not just applying. So ask why. Okay. If you don't ask one day, other will ask you. Can you explain? Can you explain it? Right. It's not just about you know how to do it or not. Yeah, everyone can do it, but not everyone can explain it well. Yeah. Okay. But I'm also glad that you guys put your honest feedback in. Okay. So it's this kind of conflict that we can grow together. Right. Why people go to gym? They injured their muscle so that the muscle can grow stronger. So this is kind of a mind stretch for you to grow a stronger. I don't want you to stay inside your comfort zone for too long. Okay. Right. So the mark of this test, doesn't define you. Okay. You have to be yourself, work hard, and then fight for it. I'll decide what to do with the scaling. Okay, the average is about 45. Okay, the average is about 45. Two of you got 90 and above. One of you is eating, and then one of you is sing. Hey, forgot the name. What's the name? 定语. Okay, 定语, yeah, 定语. 定语 and 一定, both of you. And then there's a gap between these two and the rest. Okay. It's okay. So you just keep on working hard. What's your weakness? You improve. Okay. It's usually it's not the best one that stay inside the industry. Are those who persevere that stay in the industry. Okay, any industry. Let's say mathematics. So only those who are persevere will stay. Not the best one. Best one, maybe they can opt for other stuff. Right. So if you really like it, really want to do it, persevere. Like what Venus say. Right. Okay. So anything you want to ask about the mark before we go to discussion of question? So don't write on your paper. So later, when I discuss, right, if you think you have some marks to claim, so you just take a note. After the discussion, you can come and claim your marks. Okay. Maybe we start the discussion first of question. Okay. So first question, it is hard or easy, depend on how you view mathematics. Okay. So there's one key one misconception here. So Wai Ying said that he thinks that every statement is true, is it? You thought. Okay. So one of the misconception is you try to accept everything what people say. Okay, then you will think that everything is true. Yeah, actually it's not. The easiest thing to do is to find counter example first. Usually, if it is wrong, counter example is easy to construct than proving it. Okay. So usually we will try and find counter example first. Let AN be an arbitrary sequence. Okay. If AN is bounded, let's look at part 1. If AN is bounded and monotone, then it converges to one of its bound. Okay, true or false? What's the tricky part here? When you see this, what's the first thing you think of? Any theorem? Monotone sequence theorem, right? Okay, if it is bounded and monotone, then it converges. But it doesn't tell you what to converge to. Okay, so I say, does it converge to one of the bound? What bound? Anything, your choice. Okay, so this is the key part that will go wrong. Okay, so if I pick a sequence -1, constant sequence -1, it is bounded. Okay, I can bound it by 2 and -2 from below, 2 from above. It is not increasing because it's just constant. Okay, but AN converges to -1. Okay, I think I mentioned this, not this particular example, but this problem, this concern when I introduced the monotone sequence theorem. Okay, if you listen in class, then you will notice this. And I also draw out the picture that time. If second part, if AN converges, then AN is bounded. Okay. This is true. Okay. So how I prove it? just use contrapositive. So I play some tricks with logic. If AN is unbounded, then by definition it diverges. Okay, if it's unbounded, then it diverges. Right? Does it make sense? Unbounded, then diverges. Okay. Some of you are quite good. You use the epsilon delta definition you have learned before. Okay. Because it converges, right? You can control after big N, you can control all the term within the one epsilon you pick. And then what happened to the previous? Previous are first few N terms. So you can just pick the largest one to bound it. Okay. Yeah, I think some of you quite good. For the third one, for all real numbers, okay, let's say the absolute value of our sequence converge to C, any real number. Then the original sequence also converge to C. Can you relate back what we learned for this sentence here? What's the similar sentence we see in lecture notes? When C equal to 0, it is true. So I try to generalize this. Can I put any non-zero C or not? Is it true or not? Okay. So it's also false. Because if I get the -1 alternating sequence, okay, and I compute the absolute sequence, limit for the absolute sequence, it get to 1. Okay, but the original sequence diverge, right? This is the example we keep using in the lecture. Alternating -1 sequence is diverging because the limit doesn't exist. Right? Okay. For the fourth one, if the limit of AN go to 0, then the series converges. What's the similar statement in the lecture notes? Sorry? The opposite. Okay. If the series converges, then every term will go to 0. The limit of the sequence will go to 0. Okay, so I swap it. Is it still true or not? No, right? Because this is exactly the harmonic series counterexample. Okay. Yeah, so most of the thing we have done in the class, okay, except I think 3 or 2. Right. 1 and 4 we briefly mentioned. 4 we mentioned it. So 4, quite a lot of you can do it. 4. It's good. Okay. So everyone is okay with finding counterexample, right? How to find the negation of this. I mean, how to disprove or disprove this. So if P then Q, so you need to show if P then not Q, so that you show that the statement is false, right? Okay. Any question on this part 1, question 1? No? Clear? Clear? Okay. I think one comment from Ting is quite true. For this kind of question, right? Okay. If you suddenly do on the spot, I don't think you can do it for most of you. So in real life, you need to practice yourself. Okay. If I swap this, is it true? If I change this, is this true? Right. Okay. You should start practicing in real life. You get what I mean? So if, for example, if the statement is true, okay, is the opposite is true? Okay. Or if I change some of the variable, is it still true? Okay. So this is how we create new theorem, new statement that's true. Does it make sense? Make sense? Huh? Okay. So this is try to train your mindset. Okay. Try to train the way of you thinking. Okay. No question on question 1. If you have later, we can come back also. Okay, second part. Determine the series whether it's converge or diverge. Most of you can do question 2, right? So use ratio test. I admit that the first one and the third one is hard. Okay. The original question doesn't have hint. Actually, I already put this hint in. And then few of you success. Yeah, 2 of you is Dingyu and Yiting. Okay. So you need to follow my hint. And then try and think how this hint connect to the original question. Okay. So the first one, I say that n is greater or equal to ln n for all n in the natural number. So at ln n appear in the series. Okay. No, so you will try to think that whether I want to use comparison test or not. Okay, so you should start from that idea. Okay. So indeed, I use comparison test, but to show that the bigger sequence or series converges, okay, I need to use another test. Okay. I use a limit comparison test here. I think some of you use other tests that works also fine. Yeah, anything it works, if it is fine. Uh, so I put 2 marks if you can see what the hint's trying to do, and 2 marks for showing the sequence converges. Okay, and then yeah, so the hard part about these 2 questions is we use multiple series tests together. Okay, it's not just like tutorial question, just use 1 test or 2 tests is enough. Okay, we combine few tests together. Okay, so when we try to do limit comparison test, we compare to a convergent P series. So by the limit comparison test, the greater series converges. So by ordinary comparison test, the original sequence converge. Series, sorry. Okay. Question 2 is relatively easier. Just use a ratio test. Okay, I think it's the most easiest one, easiest way to do it and to see it. Okay, so the ratio is 0, so it converges. Third one. So why I give that hint? So need to try and show that hint whether that sequence converge or diverge. I think some of you try consider the hint, so that it diverges, and then somehow you did something wrong with your L'Hopital rule. Okay, when you compare them. Okay, but so far it's okay. So I give 3 marks if you consider the hint and find out what happened to that series. And then if you can compare back to the original series, I give you another 3 marks. And then it diverges using the limit comparison test. Yeah. You don't need to follow this method here. I think some of you also using the other method also work. So I also give you mark. This is only just one suggested method. Any question on this series question that you want to ask? Series question. No? Okay. Just go on first. Okay, question 3. Is this question similar to what we did in the assignment? Is it similar or not? This question, power series, term by term differentiation, radius of convergence. Is it similar? Similar or not? Don't recognize. Is this question similar to the assignment question? Not really. Yeah, it's a little bit harder, okay, but it's actually similar. Okay, we want to find the radius of convergence for power series. Okay, and then using term by term differentiation. Okay, and then try to figure out when you substitute some number into the x equals to some interesting number. So the interesting number here is ln 3. Okay, so you can write ln 3 in terms of some infinite series here. Okay, yeah. So when you do this question, right, you cannot, yeah, I don't give you time to think much. You just need to do what is your first intuition, what is your first thinking. You just do it. You cannot think long. Okay, there's no time for you to think. So when you see this, you should remember what happened in assignments. So you just keep going on, keep the momentum. You cannot stop. Okay, once you stop, then it's a little bit hard for you to pick up. Okay, that's why last time I give you advice, right? If you start, just keep going. Don't wait. Okay, yeah, don't wait. Just keep going on, going on, going on, going on, and come back and go on, go on, go on. Okay, yeah. So I would say this test is like a marathon. Yeah, marathon. Okay. So first question is what? Okay. So determine the set of real numbers for which it converges. So you want to determine the interval of convergence. Interval of convergence. Yeah, right. Interval of convergence. Okay. So first you find the radius. Okay. Once you find the radius, I give you 2 marks. And then for the endpoint, I give 2 to 3 marks, depend on the endpoints. Okay, because one of the endpoint involve more steps. And then last mark I will give to the conclusion. Okay, so it converges inclusively at -1, exclusively at 1. Okay. At 1, it diverges because you can compare to the harmonic series. And then at -1, it converges due to the alternating series test. Okay, but a lot of you here, you recognize that there's some similarity with harmonic series, but not here is 1 over 2n plus 1. You are adding the odd number part. Okay, but in harmonic series, you have the even part. Right. So why is it still true? Okay, so there's some subtlety here. Okay, it's good that you manage to see this, but there's still more detailed stuff to see. Okay, there's more detailed stuff to see. What's question 2? Oh, question 2. So let me go back here. So question 2 says that explain that the radius of convergence of fx happens to be the same as the radius of convergence of series in part 1. Okay. Wow, so many fx. So I think need to change one of them. Okay. So you can see that actually our question start with this 2x to the power 2n plus 1 over 2n plus 1, right? Okay, but part 1 asks you to find interval convergence for another series. Okay, right. So you can see that how this question break down the original question. Okay, so this is the most basic stuff we need to look at. Okay, and then we see how part 1 can apply to find something for the original function here. Okay, so this is why we break it down here. Okay, so why is it true? So one way to see it is you can straight away do radius ratio test, which is most of you are doing. Okay, you can do ratio test, just compute the 1. Second, how do you do it? Second is you think of how to re-express the function as the function in part 1. Okay, so it is just 2x. It is just 2x multiplied by the part 1 function, substitute by x squared. Okay, right? Okay, so multiplying polynomials doesn't change the radius of convergence of your Howe series. Okay. Substituting the variable also doesn't change. Okay. Make sense? Right. This is what we did in the class also, right? So we multiply some x or x squared to the Howe series doesn't change the radius of convergence. Okay. Part 3. Okay, part 3 differentiation. Okay, so you differentiate your f. Differentiate your f. So you this question is just asking about the term by term differentiation within the radius of convergence. And then you rewrite your series in terms of geometric series. Okay, part 4 is a little bit tricky. Okay, it's a little bit tricky. Okay. But the hint asks you to calculate f applied to half. Okay. F applied to half. So how you do it? So actually, you also observe that part 4 have a ln, okay, ln 3. And then part 3 have a function of 2 over 1 minus x squared. Okay. If you integrate 2 over 1 minus x squared, you get ln something, right? Okay, so you need to try to figure out how this ln managed to combine with the f of 1/2. Yeah, this is the tricky part. Okay. Yeah. This 7 mark is kind of tricky. Okay. So what I did here is I integrate the part 3 function in part 3. Okay, integrate the function in part 3 from 0 to half. Okay, how do I integrate this? So I use the partial fraction. Okay, you break this function into 1 over 1 plus x and 1 over 1 minus x so that you can easily get ln of 1 plus x and ln of 1 minus x. Okay, so it turns out that this is just ln 3. Okay. I also admit that this is not obvious why we put this, but it turned out to be ln 3, which is what we want. Okay. So if you try other number, you might see that if I sub that number equals to 0, you will get ln 3. Okay. Yeah. And then, so also one advantage of putting 0 is if you evaluate f at 0, because it's a power series, right? So it goes to 0. Okay. So if you simplify your infinite series, you get exactly what you want when you apply the infinite series at half. Okay. I also will put out this solution later. Okay, after the course, after the lecture. And later you should take a picture of your midterm because you need to return me the physical copy. Because the school need it for filing stuff. Okay. Later you take a picture of your midterm. Okay, so question 4. Question 4 is a Fourier series. Okay. Fourier series of pi minus absolute modulus t, absolute value of t. And then use part 1 to evaluate the following infinite series. I think quite a lot of you observe that this is actually a even function. Okay, and then Bn is 0 because this is what we learned in class. And then I think most of you fail in the integration. Okay, when you do integration, I'm not sure it's too nervous or too excited. Okay, so you don't get the right answer, but that's fine. Most of you get the series like, let me write up. So something like -1 minus pi Eating, can you say what you get for this? What's the series you get? I think you get some form like this, right? Yeah. So what's this final series you get? You didn't finish? I thought you finished. You didn't finish? Okay. Some of you stop at something like this. Okay, maybe thingy. What do you get before you get the final answer? What's the coefficient you get? I think some alternating -1 here. For part 1. What do you get? No, just read out what you get. Okay. K square pi. Okay, K square pi. Okay. The numerator is correct, is it? Ah, can't see. Times 2. Times 2. Oh, times 2. Yeah, correct. Okay, times 2 is correct. And then what's the part after this? Cos. Cos n. Cos nt. Okay. I think most of you got this. Yeah, most of you got this. I also give you mark. Okay. But for the next part of the question, it is better you can write into this form here. Okay. Why? Because inside here, this alternating -1 will cancel with the 1. Okay. So you can rewrite your series actually. Yeah, you can rewrite your series in terms of this form. Okay. Yeah, I also give full marks if you stop at this step here for this question. But it's better to write into this form. Yeah. The only thing is manage to see this. So how do you see this? Actually, you need to try and understand your infinite series. Try to write a few terms up, and then you can see this pattern here. Okay. Yeah. Right. So when you study infinite series, right, really, you need to think about the terms inside the series. Okay. What is exactly the formulas trying to write down the number? What's the number trying to tell by the series? Okay. Yeah. So if this, then the next part will become easier once you get this form. Okay. Where you just substitute t equals to pi. Then everything will fall out. Yeah. So I would say that this second part is quite hard as well. So this is a hard mark. Very hard. Yeah. So for me, right, for me personally, when I set this exam question, I think 30 marks is for my distinction. 30 marks. So the other 20 marks coming from the first 20 marks. If you think that those are hard, then it becomes a distinction mark. Otherwise, I just set 30 marks distinction. Yeah. And then yeah. Okay, last question, question 5. Some of you missed this question. Okay. Sketch and find the area common to the two polar graph. Okay. I don't give you area. I don't give you the sketching picture. Okay. I want you to sketch it from nothing. So if you can sketch it, I give you 7 marks. Okay. Then we will need to we need to determine how to find the area. So what's the area we want? So the area we want is common to two polar graph. Okay. So it is inside here, common to two area. Okay. So you can see at this area, right, governed by two graphs here, two separate graphs. Okay, so you cannot just integrate over one graph. So you have contribution from the other graph as well. Okay. So one way is you can split this into this here plus the other contribution from the other curve. Okay. And then some of you try some more complicated way. As long as it works, I will give you marks. Okay. So the most easiest way is to find the intersection first. Okay. And then I cut the area into these three pieces. Okay. 1, 2, and 3. Okay. Notice that 1 and 3 are the same due to symmetry. Yeah. Okay. Any question or not? Before we take a break. Any step you don't understand or you confused? Okay, before we end, I want to interview. I haven't finished interviewing just now. Hello. So let's pick some different from different background or marks. Let's see how they feel. Okay. Let's see what you feel. What's your individual feeling towards this exam? When you get this exam, all right, you have a reading time, right? Okay, and then you do the exam. Okay, can you tell me like what happened? What happened to you? Like what happened to your mind within this period? Okay, so we give privilege to Hisham first. Okay, from Indonesia, friends from Indonesia. What do you think? Okay, good, very good. This is a good strategy. And then okay, okay, okay. Did you manage to come back later or not? Did you manage to come back later, or you just leave it? Okay, so you come back and do later. Sure. Yep, yep, yep. Understand. Yep. Mm-hmm. Okay. Okay. Good. Yeah. Right. Almost every question I hide one hard question. Hard question one section. Almost. Yeah. So if there are few parts, maybe towards the last one is the hardest one. Hardest to see. Yeah. So it's okay. And how about Venus from South Africa? Is it South no Africa? Where? Last time, where's the place you told me last time? Tumburan? Where's the? Oh, okay. East Africa. Okay, sure. Sorry, East Africa. So, what do you feel from the moment you take it and then reading time and then? Okay, okay, good choice, good choice. Yes, question 5 is the one that I expect you guys all of you do it. Yeah. Oh, okay, sure. Okay. Okay. I think you not. I mean, your performance is not too bad. I would say, yeah, not too bad. I would say, yeah. Okay. No, no. I mean, from my point, Okay, from my point, it's not too bad. Yeah. Okay. What she say? What she say? Ah, okay, okay, okay. I'm looking from a general, so I'm not from your viewpoint. Yeah, yeah. So we see from different viewpoint. But if people say you are good, you should yeah, that's right. That's right, that's right, that's right. Yeah, that's right. Okay, so how about let's get some more international student from China, maybe? Anyone want to? Okay, I think what Yiwei, what do you think? Huh? Okay, okay. Then at some point in the class. Okay, that's all. No, it's okay. Anything else? Okay. Eh, okay. Get another one. Actually, I'm curious about eating. Eating. When you do the question, what are you thinking? Quite hard. Okay, sure. So how you manage like come up with your answer, or you just think that it is true, then you write down. Don't know whether it's true or not. So are you 100% sure what you write down is true? No, right? So you just write down what you think is true. Okay, and then you make it. Yeah. So this is what I want you to do. What you think is true, you do it. Okay. Then when people tells you it is false, then you need to accept it. Okay. Yeah. Just keep doing what you think is true. Who else? How about get some Malaysian? Shun Lin. Yeah. I think you got a lot of opinion, right? What? I mean, okay. I mean, you decide what can share in public. Okay. What time to do? Okay. So when you're doing it, what are you feeling? The moment you write it. Yeah, yeah, yeah. Sure, sure, sure. Okay. Okay. So, okay, let me imagine a scenario. So you're writing down. No enough time, no enough time, no enough time like that. You see? Okay. Yeah. So that's why I want to train you don't have too much of what do you call that? Chinese is 杂念. English is what? Yeah, of course, it's difficult. So you still need to focus. Like, I mean, you need to keep focus. Okay. In English, you want to keep focus. Okay. Don't be distracted by negative things. Because that's the only thing you can do. What else you can do? Right? What else you can do? The only thing you only can do is focus. Oh, sure. Definitely. Definitely. Definitely, yes. So that's one of the thing I want to train you. Yeah. Yeah, just focus. Yeah. I mean, I also take exam about I think almost 1,000 times, I guess. I think you guys almost test around the same few hundred times. I mean, including quizzes, small tests, all the tests, right? So tests really can shape a person's personalities. Okay, so if you just think this is hard, then I also can't help you. So you need to think about what you can gain from this test. Right. Okay, let me get the last one. Jimbo, Jimbo. Jimbo, you missed one question or how? Why? Why miss one question? Already got reading time. What happened during the reading time? Huh? Just read until question 4. Did you read the first page or not? You didn't read the first page. Okay? So you see, first page doesn't print for nothing one. I write down already 5 questions, right? So if you read until 4th question, you should think there's another one, right? Okay. So follow the instruction, okay? Every page is very important. Other than that, when you write solution, what you are thinking? I just do. Okay, this is the right mindset. So you just do, keep doing. Okay, do until time stop or until you finish. Either one. Surprisingly, none of you mentioned about cheat sheet. Is cheat sheet useful or not? Useless. Okay, that's very good. This is also my feeling when I get the test. Do my test last time. It's useless. Okay. So if you don't know, that means you don't know. Okay. No matter how many tools you have, you also don't know. Okay. So yeah. So try to think about whether you know subject matters right or not. Okay. So redefine how you learn a thing, how you know a stuff. Okay. Whether you really know into your heart. Okay. Redefine it. All right. Okay. So let's take a break until 3:23 and then we'll start with lecture notes and then return me your physical exam sheet and then you can get your cheat sheet back. IT 还没有来。Hello. Hello. You want? Okay. Yeah, here you can place it here and then get your cheat sheet back. Oh, you want to ask? Okay.
觉得这个写的挺少，但是我觉得所有的就是我想写的东西写上，
你写了
对
？OK。
就是其实就是浪费很多地方，我觉得。
哦，没有，我再看看你做了什么。
就是这个
OK。
就是做了什么？然后有这个不等式，这个要根据那个 HBF 的大于就是那个极限，然后这个然后对他来说的话，用那个 integral test，他可以带回来，然后他就用那个directly 什么嘞？
哦，我知道你在讲
comparison。
哦，你是这个意思。哦，气氛的话，哦，我知道你说什么，你是说 comparison。感觉
就是写的这个这个是2，然后这个地方写的不是没写那个
看看我给几分给那个 continuous 的东西。
毕竟那个 project 它那个就是它一定是要我们没去做过的，
啊，没有证过的。
一定是要我们
因为这样才能够就 extension。对。
我放弃了，
我这里想一下，为什么呢？
就是我那个选题放弃了，我又发现了好多其他的 submission method 也很难，然后我就想一些别的。
可以啊，可以选，只要选容易的就好。
因为这个里面我看不懂东西，
可以啊。
有一个叫模拟立场库的东西，
哦，OK，
我
body constant 啊，
没看懂，因为我
可以有些东西可以直接用。呀，constant 罢了，应该是可以直接用。又不是，如果不是一个新理论的话，就给我看一下啊，给我看一下啊。因为我可以给他6分，应该可以，应该可以。OK，要6分的。所以你再看一下，再看。
这个写的很烂，但是
94分，所以你哪里还要分？
就是
要告诉我。
这个题应该是
对，
我不知道可能
你不知道扣在哪里，我看一下啊。这题是什么？
我没有把它那个就是编辑过，就是把它分开的那个给我写出来。
哦，OK，好，就算假设你分开了过后呢，
就是然后把
你的 constant 呢，你应该要有一个 constant 啊，对不对？
对
对不对？
没错。
然后你要解决这 constant 的问题，他们有解决有些人。
本来是零在对。
F0的时候，也是在算 F0的时候，其实，
对，
给我看一下啊，可是可以给你一些分啊，其实可以给多2分，可以给多2分。行，等下我一看就。看吗？
没有，就是对，剩下的应该就是我有的。
OK，
这个，当时他应该把零带进去，我说为什么带2开？那谁要如果2开可以？
没有啊。OK，好，那我帮你改放。我抽个，然后我按记忆，然后改。OK， you come first。
我写的东西啊，所以
OK，
我用红笔有个的标了。如果他
OK，
没有事情啊，
没有事情。好，OK，呀，没有事情，OK。
It's just for clarification, not really just to be clear.
Oh, I mean, when you convert to L, right? Why can you assume that AN is less than or equal to L? How about converging the other one? Well, what do you mean by this? I mean, okay, don't look at this. So when you converge to L, why you write this? Why is this true? This is not true. Why is it true? Why does limit have to be always greater or equal to A?
Wait.
Yeah.
To prove that a limit, no, like sequence. This is sequence, right? Sequence. AN is a sequence. To prove that a limit, sequence is convergent. Do this, and if it converges to L, it means that.
No. Let me show you. Everything is greater or equal to L.
So in this case, this is one way.
Sorry?
This is one way.
This is one way, this is the other way. Another way is like it's just jumping around L. Also, you also can have sequence like jumping around L. Also works. Yeah. So you cannot say anything between these two. All right. Oh, you write ratio test, is it? Okay, okay. Think, yeah, I think it works. Yeah, yeah. I just mixed with.
So what exactly did I mix?
I can't remember. Let me think. Let me see. Actually, it works. I just cut marks here. I think. Let me see. Actually, oh yeah. Okay. Oh man. Okay. Yeah. Right. Okay. So actually, yes. Yes. I want you to mention things. At least you say, oh, within the radius of conversion, we can do this. Yeah. Otherwise, you can't just differentiate to my term. If I want to consider x at the other point, we cannot do this.
Within
Yeah, within a radius. And then apply
the radius of convergence is this one, right?
Yeah. Oh no, I wait. So there are two things going on here, right? So first you want to differentiate this, but this radius here is coming from when you want to use this geometry series. There are two things going on. Wait.
Expand this.
Yeah. So there are two things going on. So your miss is the first bit. So when you do when you want to do this term by term differentiation, right? You need to do it within the radius of convergence. And then after that, you want to simplify this series, and then this sum of geometries will give you another condition on the restrict further. Yeah, I took marks of everyone. Yeah. Okay. Okay. Thank you very much. Okay. Thank you very much. How about we continue next recess? Yeah. You can keep your paper first. Eh? Oh, you want to ask about test or project? Okay. You want to ask about quick one or you want to do quick one? Okay.
Question, I saw this one gives two.
Oh, okay. Okay. Yeah, that's all. Yeah, I think so. Okay. Anything else? Okay, thank you.
I need to think actually.
You can take it. Okay, so if you have more questions, right, later we can continue the second recess. You can keep your test paper first. Feel like I have to speak without mic for 3 hours today. Okay. Right. So before we go into the object. So just now I mentioned everything's have two-sided, right? Good and bad, correct? So sometimes when I listen to how you guys judge a person, right? I feel a bit sick. Right, I feel a bit sick. So this is about pride and prejudice. Pride and prejudice. 傲慢与偏见. Okay, pride and prejudice. Of course, you can judge one person, but please be reasonable. Okay, be reasonable. I give you a story. One of my principal, okay, high school, there's a high school principal. People say that she is lazy because she sleep in the office in the morning. Okay, lazy or not, sleep inside the office in the morning. Why not? Maybe she stay late. Yeah, stay out late. Of course, stay out late. I mean, why stay out late? If you do other stuff, then it's not reasonable, right? But let's say the CCTV footage show that she worked until late night in the school. But the second day, she take a nap. Is it reasonable? No? Okay. If you think that it's not reasonable, then I think you got too high expectations on people, right? So there are two things. So you can't always deduce one thing after you see a phenomenon, right? Maybe there's something at the back happening. You don't know. Okay. So when you see something is bad, try to understand why it happened. Okay. Can you help? Can you help or not? Or you just stood there and laugh? Right. Okay. Yeah. So there's something I want you to think about. So I mean, change your attitude first before you get 4.0. That's useless. Okay, if your attitude is bad. Okay. Okay. Okay, so go to the serious business now. All right. So last time we introduced this Clairaut's theorem, right? I seems to like go really quick. I says that if fxy and fyx are continuous, then fxy equals to fyx. Anyone try to prove this inside your project or not? No. Okay. So there's a condition here called the open set. Are you guys familiar with open set? No. No. Also. Okay. So let me introduce this definition here. So what's an open set of X? Okay. So we need to have some setting here, right? So let f be a function of two variables. That's why. Okay. Let f be a function of two variables. Okay. Going from say f is going from R2 to R. Okay. So an open set of X, where is this X living? This X is actually living inside the domain. Okay. Continuous at some point. Okay. If it is one variable. But now two variable inside R2. Make sense? Okay. So what's this X really? Okay. So you can think of this open set as a circle around a point. Okay. So these are all the points such that it is a fixed distance from a fixed point. Less than delta. Okay. So typically we will label this as a ball. This is a ball. No? Let me think. This is a open ball. So with radius delta centered at AB. Let me see how to put it. Okay, depend on notation. Maybe I just put the center at the top, radius at bottom. Okay. So this is an open ball. Okay. So one example in R case. Okay. What's the open set in R? What are the open set in R? Okay, you might feel weird. I give you a definition in R2, but I ask you something in R. So what's the difference between R2 and R? You just discard one of the variable. Okay. So if you discard one of the variable, the length is just becoming what? So these are all the point x such that x minus a is less than delta. Okay. What is this? This is an open interval, right? This is open interval. Open interval in R. Okay. So when you go to R2, it forms a open ball around a center AB with radius delta. Okay, but you never reach delta. Sometimes we consider closed ball when they are equal, when it is equal to delta. Okay, so this is the definition of open set. Yep. Can close the line. Okay, I try. What? Okay. Okay. Open set. Yeah, this is I just trying to introduce what open set is. Okay, and then the next question is a really interesting question by Ding Yu. Okay, by Ding Yu and Kyron together. They come and ask me. Okay, so last time we are really naive about this implicit function theorem. Okay, implicit function theorem. So we have a function in terms of xy equal to 0. And then what we computed last time? What have we computed last time? We says that dy over dx is equals to partial f of partial x over partial f of partial y, and then take the negative. Do you remember this? Remember this? Okay. So last time we have the condition y. We have condition that if f, so when fxy equals 0, and then we deduce that del f over del x is also 0, right? Is that right? Right? Okay. So similarly, you should ask also, I also can deduce that del f over del y is also 0. Okay. So in this case here, we have 0 over 0. So what's 0 over 0? Okay. So in fact, there's some hidden stuff inside this implicit function theorem. Okay. So what we have to consider is where the point where del f over del s is 0, but del f over del y is not 0. Okay, this only works for this point. Okay, it only works for these points. Okay. Can you anticipate what happened if del f over del x is 0, del f over del y is also 0? Or where the point is del f of del y is equal to 0? What happened if del f over del y is 0? What happened? With respect to y direction, it is 0. So what kind of tangent line you get? With respect to x is 0, you get horizontal. With respect to y, you get vertical, right? So you get vertical tangent line. So what's the dy dx for vertical tangent line? What's dy dx? I think we roughly saw this example once when we do polar graph. Yeah. Tangent plane. What's tangent plane? I didn't say tangent plane. Tangent line, tangent plane. Okay, same. Okay. Okay. Generally, tangent plane. Okay, generally tangent plane or line if you want to. Yeah, line or I mean, in our setting actually tangent plane, tangent line actually in our setting here, actually tangent line, dy dx only. We are not dealing with a partial derivative. Actually tangent line here, because in our setting here give a line. Okay, I give you an example, right? So let's take an example. When we talk about this statement, right, let sum f equals 0, let sum f equals. So do you have an example or not? Actually, we do. Okay, so we take fxy equals to x squared plus y squared minus 1. Okay, what's this? If I let this equal 0. Huh? Consider x squared plus y squared minus 1 equal to 0, which is a circle. Okay, which is a circle. Which is a circle. Okay. So df over dy is 0. Is the vertical tangent, is the point with a vertical tangent line. Okay, maybe around here. There are two of them. One at 1, 0, the other at the minus 1, 0. Okay. So what's dy dx there? What's dy dx? What's the gradient? Infinity. Okay. So in fact, you get something infinity. So 0, yeah, 0 over 0 here, something you get infinity. Okay. Okay, I think it and Karen. Okay. Very good question. Yeah. Because these notes, right, they are not complete because not detailed, because they mostly care about calculation. But because you are a math student, you should be critical to these notes. If I manage to see earlier, I will fix it earlier. But if I like overlook it, then I need your help. Okay, and then we will reproduce this note with a proper level. Okay. All right. But I summarized this in the last lecture notes, so you can read it. Where you can read the whole setting here. There's a few remarks to help you understand it. Okay, I rewrite this implicit function theorem. So really, you need to start with a function in xy equals 0, and then pick a point where that's lying on that curve. Okay, and then suppose you can find fx and fy, they are continuous, plus this extra condition here. The derivative with respect to y is not 0. Okay, then in this case, we can solve y in terms of x at that point. Okay, do you believe this or not? Or do you understand what this says or not? Y can solve as a function of x near p0. Remember why we're doing implicit function theorem? Exactly, we can't express y, just y in terms of x. Okay. For example, the square just now, how you express y in terms of x. Okay. But you can do it for part of it. Okay. Remember, like what we said last time, we can split this graph here into two parts. Right. So the top part maybe will looks like y equals to square root 1 minus x squared, and then the bottom part is minus of square root 1 minus x squared. Okay. So locally you can do this, but globally you cannot. Okay. So you need to use two of them to patch them together. Okay. So this also works for general manifold. So you can solve it, and then you can use the same formula for x, y that are near to the point that we mentioned just now. They have special property, which is the derivative with respect to y is not zero. Okay, so this implicit function really just work for the points that is non-zero for the denominator part, which is the partial derivative with respect to y. So whenever you see this, right, see this kind of expression, right, you need to make sure your denominator is non-zero. Yeah, always. There's no accident. You have to make it non-zero. So it's an interesting question to ask, what happens if the denominator becomes zero? Okay, so in this case here, the gradient become vertical. Okay, become infinity, become vertical. All right, is it okay about this implicit function? Okay. Okay. Question. All right. Okay. So let's recall what we did, what we have last time. Okay, let's recall what we have last time. Okay. So what's the definition of directional derivative? What's the definition of directional derivative? Need to call name. Hmm. Jiawen, what's the definition of directional derivative? You know? What was the definition of directional derivative? Do you know or not? Yes, okay. So what is it? Just say what you know. It doesn't matter if wrong or right. Not enough. Not, hey, like this, not enough time in exam. Oh. How? Yeah. Is what? Is what? Okay. Yeah. Good. Yeah. That's all. Yeah. Why you? Yeah. Don't hesitate. Yeah. Just say what you think is right. It's wrong. Also, never mind. That's why we come here. Right. So recall what's the definition of directional derivative. So what ingredient you need? What ingredient you need? You need a unique vector. Okay. You need a function. Okay. Function in two variables. Okay. So we want to define the directional derivative at the direction of u. Okay. Of f at the point P. At a point P. So I also have a point P. Point P. Okay. So how do I define this? So this is, remember the special limit we are looking at. So we look at the difference of two functions. One of them is f of P plus HU. Okay. So why P plus HU? So P is the point. We look at from the point at U direction. Okay. Small change in U direction. Minus FP itself over H. And then we see this limit going to 0 actually. Getting closer, closer, and closer. Right? Okay, until we reach the original point. So actually, Ming Xiu asked about a question here. So why unique vector? Okay. So none of the adjective in theorems or definition is useless. Okay. So why we put this adjective in? So why we put unique? Actually, it's not clear from this definition itself, right? I can literally put any vectors, it works. I just compute a limit, okay? So why we use unique vector, it will become more apparent later, okay? So this is mathematics. Sometimes we are building up stuff for what we want to find later, okay? Not for now. So mathematics is like this. We start with what we want to do, and then we build things. So when we present, right, instead of going down from the bottom to top, we go from the top to bottom. We start from nothing to something that we want to know. But in reality, we start from what we want to know, and then we try and figure out what we need. Okay. Yeah. So this is one of the trick in mathematics. Okay. So you can see that if you want to find directional derivative, you need to go through the limits. Okay. But we have a theorem last time. Okay. We have a theorem last time on how to find this directional derivative using the partial derivative. Okay. So how to use that theorem? So what's the condition of that theorem? So last time what we have, okay, let's write down what we have first. So we can write, there's a formula of this derivative in terms of our x and y partial derivative. Okay, let me ask a question. Inqi, Inqi here. Is it you? Inqi. Okay, Inqi. So is this formula always true? Is this always true? Yes. No. Okay, this formula is not always true, right? Okay, so there's some condition here. Okay, if you go through the theorem, okay, the statement of the theorem, unfortunately, this is not always true. Okay, so why is this not always true? Sang, when is it true? When is it true? Any idea? No idea. Okay. I mean, okay, sure, no idea. So last time we go through this theorem says that if f is a differentiable function, okay, only we get this formula here. Okay, only if f is a differentiable function, then we get this. Okay, not only we get this actually we already get let me see. Okay, yeah, we get this. So f has a directional derivative. Okay, that is this formula here. Okay, so you need to make sure your f is differentiable. Okay, why? You can see that in this formula here, right? You need to differentiate your f with respect to x and y. Okay, so you need to make sure these two numbers exist first. Okay, make sense? Make sense, huh? Okay, so let's do one quick example here. Let's say we have this function surface, define a surface here, and then we want to find the directional derivative at 1, 2. Okay, so how do we find it? At the unit vector that is making angle of pi 6 with the positive x-axis. So let's draw out what is this question really telling you to do, right? So you have a unit vector, okay, u. How I encode the information of unit vector? I just write the length of u is 1, right? This is the unit vector, it means. And then make an angle of pi/6. Okay. So if you know more, actually this is a vector on the what you call that? You guys know root of unity or not? Root of unity? No. Complex number? No. Okay. No. Okay. It's fine. Okay, never mind. I don't want to talk about that. But how do you find this unit vector form? What's the xy for this unit vector? For you to create a pi/6 angle from x, how do you figure out what is the x and y for this u? Any idea? Huh? What do you use? Don't know. Cos pi/6 and sin pi/6. Right. Okay. So is this length 1? Is this length 1? Yes, right. Because cos square pi/6 plus sin square over pi/6 is length 1. So you can see that all the length 1 vector actually lies on a circle. Okay, circle of radius 1. Okay, so every point on this unit circle, right, can be expressed as cos theta comma sine theta. Okay, make sense? Okay, so what's this two number here actually? Cos pi over 6 is square root 3 over 2 and 1 over 2. Okay, so we want to find directional derivative with respect to this direction. Can we use the formula or not? Can we use formula here? Why? Polynomial is always differentiable, and then yeah, and then composite of product of polynomials is still differentiable. Okay, so since f is differentiable, okay, good. By theorem, du f xy equals to fx xy times a plus fy x yb. Okay, so what's the f differentiate with respect to x? So we should get 3x squared minus 3y, and then multiplied by our a. Multiplied by our a is just square root 3 over 2 plus differentiating function with respect to y. You get minus 3x plus 8y times b. Okay? Yeah, so this is the formula. Maybe you can simplify further if you want. Okay, so try and simplify further. But if we want to evaluate xy at 1, 2, okay, 1, 2. So you can just substitute all your x with 1, all your y with 2. Okay, so in the end, you will get, let me just write up, 3 times 1 squared minus 3 times 2 times square root 3 over 2 plus minus 3 times 1 plus f times 2 times half equals to 13 minus 3 square root 3 over 2. Okay, you can check the calculation. But this is the answer we get here. Nothing interesting about this particular number, but the point here is you need to know when to how to find your directional derivative. Okay. Yeah. Okay. So okay. So this is just calculation. So you can see that what's this formula here actually doing? Okay, what's this formula here actually doing? Okay. There's another way to write this formula out. Okay. Can you see that this A, B coming from a vector? Coming from a vector, right? Okay. And then this can somehow organize into a inner product or dot product. Sorry, dot product. Okay. So if I write the two partial derivative as a vector dot with AB, I will get exactly the linear combination above. Okay. So you can see that dot product is kind of useful in mathematics. It seems like it appears everywhere, yeah, even in calculus. But remember that when we derive this equation here, we didn't use any vector, right? I mean, we didn't use any linear algebra, right? We just take limit, right? We just consider the continuity. But somehow linear algebra pop up again. Okay. Yeah. So there's a big project, right? Linking different area of mathematics. We call the Lang program. So we are trying to link algebra analysis, and all other field together, which we call Lang program. This another big topic here. So what's this? So this is direction vector, right? So how about this part here? Okay, we need to give it a new name. Okay, we call it the gradient. So we call this a gradient in a two-dimensional function in two variables. Okay, and we denote it as del f. Is this also called del? Nebula f. Okay, nebula f. Okay, this is nebula f. Okay, I call it nebula f. Okay, so in this case, we will write it as nebula f dot with w or u or w. Just fix it one w. Okay. Right. Okay. Okay, so just try one example. I'll try one example here. So find the directional derivative of this function at the point 2 minus 1 in the direction of the following vectors. Okay. So can we use the formula of directional derivative in this case? Yes. So why? Because f is differentiable. Okay. So how do we use this formula here? So there's another way to find du now. So our du f at xy is equals to the function, the gradient of the function dot with the vector u. So now it's v. So let's turn it to v. Okay. So what is nebula f? What's nebula f? Nebula f is del f over del x of comma del f over del y dot with v. Remember that the directional derivative is defined for vector that are unique length. Okay, good. How about this vector? Is this unique length? What's the length of this vector here? What's the length of the vector, Shimei? What's the length of this vector? Still remember how to compute the length of vector? Square root. Square root what? Any guess or wrong is okay. Any guess? 2 square plus 5 square. Why got minus 1? Oh, wait. So this point, minus 1 is the point. Okay. So we are interested in the direction of v, which is 2, 5. So we are now compute the length of v, not the point. Right. So it's a 2 square plus 5 square. Okay. So you can see that dot product pops out again because we want to find the length. Okay. So here our length is square root 29. Right. Okay. So to map v into a unit vector, what do you do? Huh? Normalization. So what's normalization? What's normalization? Okay, good. So we consider the vector v divided by x length. Okay, so this is what we want. Okay, so next you need to compute everything. So you need to compute everything. So what you get here is 2xy cubed. And then the other one, you get 3x squared y squared minus 4. Okay. And then dot with this vector here. So it's just 1 over square root 29 times the vector 2, 5. Okay. Yeah, so you can simplify this. Okay. In the end, if you want, you can check that when you substitute xy at 2 minus 1, you will get 32 over square root 29. Okay. Yeah. Okay. So there are two ways to get this, not two way, but a different way to see this directional derivative using the gradient. Okay. So similarly, you can extend this gradient to 3 variable, 4 variable, n variable, what any dimension. Okay. So you might want to ask, what's the use of this gradient, right? Okay, what's the use of this gradient? And then why is it called gradient as well? Okay. So let's see what kind of property we have. Okay, so this example I just left as a homework. I will provide solution, you can try yourself. So maximum rate of change. So a function increase most rapidly at a point P in the direction of the gradient with rate of the length of the gradient at that at that point P. Okay. So what does this means? Okay. So what does this means? So so we have this. What do we have? We have this directional derivative at P is equal to the gradient at that P, okay, dot with U. Right? So how does the length of gradient comes in? Right. Okay. So when you have this dot product, right? Remember the formula for dot product? When you dot two vectors together, you can extract the information of the length and the angle between them. What's the formula? What's the formula? Is the length the product of the length of two vectors, okay, multiplied by cos of the angle between them. Okay. So when this number is the biggest, you also know that the length of U is just 1. Okay. When does this get the maximum number? You get a number, right? Length is a number. Cos theta is also a number. Okay, so product of number is you get number, real number. So when does this have the maximum number? When does this have the maximum number? When theta equals 0, okay, or when cos theta equals to 1. Okay. So this means that if what? If the gradient, okay, if the vector of your gradient align with the function you differentiate, then you get the most. Okay, you get the most. So this says that the gradient is maximum when cos theta is equals to 1, okay, or theta is equal to 0. Also can equal to 2 pi, right? But it's just opposite direction. Okay. When U and delta of neighbor of f, which is the gradient, are in the same direction. Same. Okay, and then we call this the maximum rate of change. Maximum rate. Okay, we call this maximum rate of change. Okay, let's keep going. So suppose there's a bug. It's located on the surface y squared minus x squared, z equals to y squared minus x squared at the point 1, 1, 0. So in what direction should it move for the steepest climb? And what is the slope as it started up? Okay, so it asks where is the slopest climb? Okay, when is the maximum rate of change happening? Okay, so when is the maximum rate of change happening? We discussed just now. In which direction? In which direction the directional derivative is the largest? Huh? Which direction? Which direction? Sorry? I mean, okay. Okay, good. Cos theta equals to 1. So when you say cos theta equals to 1, right, you are comparing two vector. Okay, so what vector you are comparing? Huh? Sorry? So the gradient of f and the direction you are going. Okay, now you want to decide your direction. So you compare your direction with the gradient of f. Okay, so gradient of f give you one vector, and then you want to decide which direction you want to go, right? But to get the maximum, you need to go with the direction of gradient. Okay, so from this function here, you can get nebula f, right? So what's the definition of nebula f again? It is del f over del x, comma del f over del y. Okay, this is most common notation in linear algebra, but sometimes we also write it as a row vector, which is del f over del x, comma del f over del y, and then we use this I'm not sure what bracket to call this, I forgot, but using this arrow bracket for now. Okay, this is a row vector form, this is a column vector form, this is a row vector form, this is a column vector form. Both are acceptable. Okay, both are acceptable. Since we are living in calculus, right, maybe we stick to this one. I'm not sure why, but calculus like to use this notation. Maybe they start off differently and then somehow they meet together at the end. Yeah. Okay. So these are just notation. So so what is del f of xy in this case here? So we get, okay, let's keep with this notation, minus 2x comma 2y. Okay, so we have to follow this direction at the point 1, 1, 0. Okay, so what direction we get in this case here? We get minus 2 and 2. Okay, so if you stand on the point 1, 1, 0 and go along minus 2, 2 direction, then it will be the steepest one. Okay, so what's the slope? Okay, this is the slope. What's the slope mean? What's the slope mean? What's the slope mean? Slope in a one-dimensional case is equal to the gradient. Okay, you want to get the number. Okay, so how to get a number from this gradient? You need to take the how to get a number from a vector. What's the natural thing? What's the natural thing to do to get a number out of a vector? Take the modulus, or take the length. Okay, take the length, or take the norm. Okay, take the length. So the length of f gradient of f11 is just 2 square root 2. Okay. So what do you have all together? Let me make a conclusion here. Okay. So the bar should move in the direction -2, 2. Okay. And the slope is started out is 2 square root 2. Okay. So let's look at the picture here, right? Let me see, do I have a picture? Yeah, I do. So you can try and plot out this y square minus x square surface, okay? And then try and find where is 110, okay? 110. So 1 on the x around here, 1 on the y around here, 0 around here, okay? This dot here, okay? So which direction you should go? Which is having the steepest slope? Okay, this is the question asking. Okay, so the answer is you go the direction -2, 2. Okay, which is where? Which is in this direction. So maybe in this direction. Okay, and then the slope is 2 times square root 2. So if you compute the gradient here is 2 square root 2. Why we don't use gradient here? Because this gradient, like, I mean, so gradient in higher dimensional is a vector. Okay. In low dimensional, I mean, in one dimensional, gradient is just equal to the slope. Okay. So when you go up dimension, gradient become a vector. Okay. So if you want to compute the slope, then you need to take the length of the gradient. Yeah. Okay. Okay. So should we take another break or not? Yes, sir. Okay, just take another break until only 10 to 30. Okay, let's take another break until 4:30. And for those who haven't give me back, haven't take yours, you want to do so?
你讲那个波是
Ball? Oh,
B
open set?
B L L 的，
BALL?
你的那个 open set 是什么波？
Yeah, BAL. 我叫它 ball 对，因为再高一
我记得这边里面有。
哦，有些哈。因为 OK， 刚才我们其实你只看到 circle 吧，但是generally 是 ball。
你把它
你可以这样子讲，但是就是说它 generally 它叫做 ball，就是因为 higher dimensional 的时候它就是一定 ball，你到 3 dimensional 它就是 ball。
可是然后我们继续的话，因为我看不到声音，还是讲那些波。
So 第一个 So one variable 是 open interval， two variable 是 circle， 3 variable 是 ball， 但是 in generally 我们叫它 ball。
我记得他好像扯到 x 用比较高，
讲牵扯呢 ball。
因为我记得我之前在读博的地方，
呀，
那时候还有讲到我看过的。
对，
然后好像他们计算那个，就是算那个，因为我们只因为 descent 不能准确有一个 一个英语课里边会把
啊，对，
他们是用Epsilon delta。
I mean epsilon delta 只是一个号码罢了，只是一个号码罢了。因为它 ball 有分 open ball 或 close ball，close ball 就把它的那个
可以代换。
旁边收有有 open 叫 open。对，没有，in general 我们叫 ball 吧，对。耶，
这个
对，
我下面有写那个 ASBN，我后来有加上一个，就是这样可以吗？
你用什么东西啊？都
就是找了一个比它大的，然后它是
这问题是他们是一体的哦，
就是不能拆开，
不能啊。BN 是从另外一个 series 来的，对吧
就？是我找了一个 BN，然后它是
那个问
conversion，然后
没有，那一个不是那样用的，它这个是叫做一体，这整个都是 A，不是上面是 A，下面是 BN，
是啊，
对吗？你在做
不是又找了一个 BN，这个还是 AN，这一整个是 AN，
哦，
我是又找了一个 BN，然后我说 BN 是 converge，然后所以它大于它，所以说它也是这个也是 converge。
但是它的 limit 是去1/2，然后你讲 deduce BN 是 converge，
啊？
你怎么 deduce BN 是 converge？
什么？
你算它那个，你是不是算 BN？
单向。
你是不是算这个是 BN 嘛，对不对？
啊，
你不是算 BN convert 去1/2，对吧？然后你怎么 deduce BN converge？OK，我问你，为什么 BN converge？
是它 limit 趋近于 L，是跟趋近于无声的时候，然后它趋近于一个是
混了，那个是 limit comparison test 对吧？是不是？
不是最初的定理嘛？就是就是 n 趋近正五层的时候，然后 limit a n 等于 L，然后它不就是 converge，不是最开始的那个。
没有啊，没有啊。你看，就算去零，它都不一定 converge，记得吗？就算去到零都不一定 converge，为什么去到 L 就 converge？去到 L 更死哦，你后面都是这一串号码再加的，对吧？对吧？是这样讲的，零都不 converge，对吧？
啊，就是
你讲的那个应该是 limit comparison test 对吗？
嗯，
那个要两个 series 拿来 compare，但是你这个是单向，可以明白吗？不明白？你给我看你的曲线，有没有抄那个？
上面那个吧，下面那个，然后就跟那里用的一样。
对，这里对，有吗？有啊，这个你是在讲这个吗？你是在讲这个吗？先
不是啊，
啊，你不是在讲这个，
不是，
但是没有啊，没有你所谓的那个东西。我们知道 series converge，如果它的 partial sum，
但是不能说跟那个 sum 是 converge，
两者不是一样，series 跟
不是
sum
就是
partial sum，partial sum converge。
就是我说明，
嗯，
我这里是说明 BN 是 converge，因为它 converge 啊，但是我不能说明
对
BN 是和这个。
对，没有错。对，而且哦，你看啊，它如果 convert 去1/2啊，就是说它后尾端啊，全部都是在1/2附近哦。这样如果这么多个1/2加在一起的话，你是不是拿到
就是它的和，
它的和应该就不 converge 嘛？对。但是我觉得我可以给你多一点分这边，因为你是用 comparison，一开始我还以为你是把这两个拆掉。
不是，我还是
给我看一下啊，之前有给几分？
给
1分半了没？
这些的。
哦，我知道，我是说我的 marking scheme 我写多少？compare 的话，我给2分，可以加一分。没有，OK。
要多的吗？
好，我放在这边，我要记得改一下。你来加号，行，要收一下。哦，
我是这个
这样啊，
那 gradient
啊，
其实就是放给高别。
人算不算 battlefield？算。
这样如果是2D 的时候，它就不是 battlefield，它是 scale。
忘记什么是 scale 跟 battlefield，但是我们之后会碰到这个东西。
然后关系那个 open border。
呀。
假如我 consider s square 加 y square 等于1，然后如果有
等于1啊，
然后
准等于1，
等于的话是
就是那一圈，
也包括那个 boundary， 也包括
只有 boundary，
就 boundary。如果是小过1，就是里面的 interior。
呀，没有错，没有错，没有错，没有错，没有错。好像 IT 今天罢工是吗 ？IT 是 IT 罢工啊。我忘记了，我看看。你在干啥？OK，好，可以。行。然后零除 infinity 的 limit exist 吗？还是啥？exist 吗？你好像做到有点快，你为什么直接等于这个？这个除这个不是 n cube 加 n 是2/24，这个东西嘛，对不对？
没错。
呀，这样呀，所以这个东西是
你算错。
算错啊。而且这题是这是 conversion，对啊，一个 conversion，所以这东西应该是呀，应该用 Lobita 吧，因为它比你。可是要不要算一下是什么东西先？看一下跟这个答案会远吗？
不会。
你现在去算一下，看一下会远吗？有 community service right the recycle item you guys still need or not? I think one of the lecturer right they want to throw away the test paper but it's confidential. I don't know how you guys manage it. You can contact one lecturer called Arash. You know him? Yeah, you contact him. He say he got a lot of confidential stuff but want to throw away. Huh? Sorry? Confidential test paper. I mean, you you can try and ask him. Yeah. You guys didn't do anything to the recycle stuff, right? How you like settle those stuff? Or give it to an maybe you need to clear it or what, I don't know lah, but you try contact with him. He said he got a lot of uh a lot of recycled paper. Is seriously? No, is it? Yeah, maybe you can ask first. You can ask first. I don't know. You can ask first. Yeah. Uh, all right. So keep continue. Yeah, continue. Okay, so we kind of repeating this tangent plane again. So this is a tangent plane to level surface. Remember what the level surface is? So we got a function, we make it equal to some constant. Okay, we move constant to the other side, and then we try to draw out the surface. Remember? Remember or not? Okay, so let you have some example in mind. So remember last time we look at this three sphere equal to some k, and then we draw a lot of sphere with different radius k, right? And then I ask you imagine what's this in 4-dimensional. Remember? This is just some so maybe I use different right? So one is K1, one is K2, and then so on. So level surface. Okay. So K1, K2, K3. Radius. So radius equals to Ki. For I equals to 1, 2, 3. Okay. So suppose S is a level surface. Okay, you can imagine of this sphere. One of them. Let P X naught, Y naught, Z naught be a point on X. Okay. On this surface. And then you trace out a curve on the surface, any curve. And then you can find the tangent plane at that point P. So that curve will give you the direction. Okay, so the direction is the derivative of your curve, right? So where your curve is moving. So R prime T is the velocity of, can I say velocity? It is the velocity, but yeah, we haven't touched the chapter 13 yet. So if you want to see further stuff, right, we will touch chapter 13 later. So it's the vector functions. So now it's a bit awkward moment here. So R prime T is the velocity of the velocity traveled by the point X naught, Y naught, Z naught along the curve RT. Okay. Yeah. Okay. So we can draw this tangent plane here. And then it turns out that the gradient, right? The gradient is perpendicular to the velocity. Okay, turns out that the gradient is perpendicular to the velocity. Is it clear why? Is it clear why? Is it clear why? Remember how we construct the tangent plane? What do we use? We use the sum of continuous partial derivative of with respect to x and y, correct? So let me write up. Let me write up. Okay, so remember how we defined this tangent plane here? Last time. So last time we have z equals to fxy. Okay. So what's the tangent plane definition here? We have f with respect to x at s naught, y naught times x minus x naught plus fy at x naught, y naught times y minus y naught. Right? Remember? Okay. So last time we mentioned that what's the normal vector? What's the normal vector for this plane here? The normal vector is what? Huh? So the normal vector here refer to the vector that is 90° to the plane. Or we call it, let's call it n. Normal. Okay, so what's the normal vector here? What's the normal vector of this plane? Huh? Oh, wait. So okay. So the normal vector here is defined to be the vector AB, sorry, the point ABC. So okay, let me try more. For a plane A times X minus X naught plus B times Y minus Y naught plus C times Z minus Z naught equals to 0. Okay. Yeah, we haven't touched this yet, but chapter 13 will touch it. So right before we go into vector calculus, we'll do this again. Okay. So for now, I just remind you. Okay. So in this case here, what do we have? We have normal vectors equals to uh, fx at x naught y naught, comma fy at x naught y naught, comma -1. Okay. Is that okay? Okay. So is this right or not, huh? Is this right? Is there something wrong with this -1? I think it's fine, huh? Okay. Okay. What is Fy in this F with respect to Z in this case? Okay. Is it true that this morning I write something out, but let's see. Is it possible to compute what is Fz of X naught Y naught? Is it possible? F is already Z. So it's just equals to 1, right? Isn't it? So is it weird coming out with this -1 here? Say again. Z minus Z. You mean, uh-huh. Okay, I mean you mean, okay, let me move this one, move this. So you mean move the Z minus Z not to the other side, is it? I know, I mean, yeah, right, sure. Yeah, that's why I put -1 here. But my point here is, so is this del F or not? Is this del f at s naught y naught? Is this del f at s naught y naught? Because just now we said that the gradient is the normal of our plane, tangent plane, right? So what happened to this? What happened to this? Any idea? Any idea? Huh? Is that the gradient of f? Why is there a minus sign popping up? Can we compute f with respect to z or not? So if we know that z is equal to fx, so we can differentiate z with respect to z, differentiate f with respect to z, right? Don't we get 1? Anything wrong here or not? Yeah. Yep. Mm-hmm. Yeah. K equals to what? K equals to fyz, yeah. Oh, okay. Sure. So how about write it into that form? So f x y minus z equals 0. Right? f x y, yeah, f x y z, right? So function in xy minus, correct? So isn't it this a function in xyz? Because your function in xy minus z, so the whole thing is a function in xyz equal to 0. So k equal to 0, right? Okay. So how? Ready my why? Oh, okay. So. Okay. Wait. I think I know what you're talking about. So let's. Okay. So okay. So this means that our f x y z equals to 0. Okay. So we are doing the implicit. Do we want to do implicit or not? Don't want. Okay, so we just compute del of f of del z of f x y z. Okay, which is we differentiating del of del z of fxy minus z. Is this right? Seems like something wrong again. Is it? Correct or not? Correct. But I think we still get one. No? Why? I mean, don't you get fz of xy minus y equals 0? What? Fxy is not set. What? Say again, say again. Oh, I mean, no, I mean, like this. Is this correct or not? Is this correct? Huh? Is this correct? But I still get one, right? Del big F. Okay, we need a del big F. Oh, we need a del big F. Correct. Okay, so how? So are you trying to say, so okay, so now we try to work backward, is it? So we want del bf to be equal to -1, maybe is the del of del z of the small xy, minus of this number here. Correct? Huh? What do you mean? What do you mean? Yeah. Mm-hmm. You mean this line here? Okay, and then fxy del z is 0. Left, right here, below here. Yeah. Fz is 0. What do you mean? Okay, I think, how about this? Let me, does everyone agree that somehow we want to fix this? Okay, because first of all, we know that small f with respect to z is 1, right? Okay, but we want that, we also want that the bf with respect to z is -1, okay? So I guess this 1 here is coming from this f, little f with respect to z, okay? So let's try this. I think it will work. So let's say I want to prove this, okay? So let me tell you, so now is how we work in Max now. So this is what we want, okay? Let's say this is what we want. Okay, this is what we want. So let me put here, we want to show. Okay, so how to show? So we work backward. So delta x, del z is a linear operator. So let's look at this two thing. What's this? Okay. So by definition, this big F is what? Is Fz of sorry, is F. Right, this one repeat already. So this Fxy why seems like I repeat a lot of things. So this is fxy plus fx minus, right? So the big F by definition is fxy minus z. Fxy. Hey, this doesn't work as well, right? If I put here as -1, then I get -1. Fair or not? So our goal is del of del z fxy z equals to -1. Okay, because here we want del of del z differentiating minus z. Does this work? Give up already. Does this work? Ah. Fx. Yeah. Oh, weird. Hmm? So how? Okay, wait, let me think whether I'm. So what we want to show is this one here. Okay, so I want to incorporate what we know, which is differentiate f with respect to z. Okay, so how we put these two together? How we put these two together? Either we can add, either we can minus. So how? Let's say I want to take minus. So let's try it. So let's say we want to take minus here. We'll get -1. Okay. So, but on the other hand, on the left hand side, we got differentiating big F with respect to Z minus differentiating small f with respect to Z. We get -1, which is del of del Z Fy xyz is actually 0. Doesn't seem right. Ah, doesn't seem right. $53. Okay, doesn't seem right, huh? I proved that the del f big F over del Z is 0. How? Any idea? How? What's wrong? So what's wrong? Let's put down what we have. Okay, so there are two things, right? Okay, so like Pishon say, on one hand, we start with this big F of xyz equals 0. Okay. On the other hand, we start with xz equals to fxy. Okay. And then we say that this gradient of this big F here, okay, at the point x0, y0, z0 is the normal vector to tangent plane at x0, y0, z0. Okay. On the other hand, last time we are given the formula for a tangent plane on this particular type of surface. Okay. Not y0, z0. Okay, which is what? Which is z minus z0 equals to fx of x0, y0 times x minus x0. Okay, now this is a good point. You check whether the definition I use is correct or not. Because sometimes, right, you're just using the wrong definition, so we can't get it. So let me write out what I think is true. Plus fy times x0, y0 times y minus y0. Okay, right. So what is nebula f of x0, y0, z0? Yeah. Okay. So just now we say that these are just the partial derivative of big F at x0, y0, z0 for for all the three directions. Okay. Right. Makes sense, huh? Okay, so how we compare these two normal vector here? First, we also can get normal vector from the normal plane equation, right? Okay, so the normal vector here is what? We have fx, fy, and 1 minus 1. Okay, so how does this compare here? Okay, so this must be something to do with the form of function we have. Okay, so how you get the minus 1 up? That is the question. So the last coordinate here is differentiate the big F with respect to Z. Okay, so differentiating big F with respect to Z. So how to get the big F from this equation here? Okay, just now we provide a way to get the big F here, which is f x y minus z equals 0. So this part on the right hand side here becomes the capital F. Make sense? Hmm? So how? I think there's something to do with the chain rule, but we need to formulate this question well first so that we can see how this minus 1 drop out. I guess. My guess. I'm not sure. Yeah, question. Huh? Yeah, I know. I will release you. We will continue tomorrow. Yeah. Okay, I mean, I will release you. So I just want to conclude here, and then tomorrow we continue to visit. I know, I mean, Friday. Okay. Yeah.
这是零元的，这个如果你还跟做这个的，这个很
对，所以怎么办呢？
它就是零啊。
我知道，所以这边怎么办
啊？
所以这个两个怎样连接？ 我的问题是，
所以说的是，它这一个不是这个东西，他说他
没有，我要连接这两个东西嘛，对不对？这样连接。
这个东西就不一了。就这里你做的时候在哪里了？对，这个
他做的时候就是 FX1，它没有这一项，
对
所以说它对外的这个就是零。
哦
这里微笑来说就是你了。
喂，所以是这个丢掉罢了嘛，对不对？
对
对啊，就这个把丢掉啊，对，对啊，最后还有没有人跟我讲？我一直 keep 住这个零，
刚一说，
我一直 keep 住这个零，我看一直 keep 住这个零，对不对？就是那个，对啊，我就是讲，I mean，对呀，就没有看到吧？哦，是不是？
我们都都
没有人看到。
他尝试跟你讲嘛，
就他是跟你讲了，
他在说什么？我不知道他在说什么。
比如他那个 Z 没有在这个 FX 里面，
这个就是零。
但是重点是我们不用看这个 equation 吗？我们看的是这个 expression 吧？
对啊，
对吧？
对
对啊，
对啊，所以这个就是不一样。
对啊，又来了，喂，什么？没有，这个等于零，跟这个等于负一什么关系？
这个等于这个啊，
对啊，这个零这个
那不是变成
不是这个等于零，零减一，这等于零减一。
啊？我知道，但是我知道，I mean，其实，哎，其实就是这个啦，其实就是这个，这就是这个，其实就是这个，就是算这个是什么嘛，对不对？这个拿来等于减一，OK，等于零减一，对，等于零减一，对，对啊，I mean something easy but like got blind，yeah，
就是你在那个 midterm 这个 solution 里面做了一个，
哪个是？
就是倒数第二题答案不是，应该是倒数第二题，那应该是八分之派方 i square，
OK，是，
这就是没想过。
签名不用紧，我知道谁来谁没来，呀，我知道，呀，要讲 project。
你们中国还是
哦，
自己变过来的吗？
等一下啊，我 stop 掉。